we have one mesh analysis, another is nodal analysis. We have studied both the methods thoroughly to solve a circuit by mesh or nodal analysis. Comparatively, mesh and nodal analysis means we have to compare both the methods which is easy to apply on a circuit. On a circuit, which method is easy or through which method we can solve that circuit easily. That's the motto of comparison of two methods. After studying both methods, which method is better? After studying both the methods, it is important to know which method is better to use on a circuit. These are given in 2 points, below 2 points. First point, you should compare number of nodes with the number of meshes. If the number of nodes less than number of meshes, if the number of nodes, if node left 5, mesh left 6, in this case we apply nodal analysis. In this case we apply nodal analysis. That means when a node less than mesh, we should apply nodal analysis. When mesh less than node, we should apply mesh analysis. We should apply mesh analysis. It is given in first. In second one, if node equal to meshes, if number of node n equal to n, then what we will do? When number of mesh equal to number of nodes, at that case we read the question. What information we have to find? If it is given, find out the loop current, find out the branch current, we should apply mesh analysis. Through mesh analysis, we can find the current, loop current easily. Okay. If current is our question, if current is our question, we will apply mesh analysis. We will apply mesh analysis. If in question asked what is the value of a node B, node voltage of a node B, voltage of a node B, we should apply nodal analysis. If voltage asked, node voltage asked, we should apply nodal analysis. These 3 points are very important. These are summarized of these 3 points. This is the shortcut of getting memory. These are description of this. When node mesh less than node, mesh analysis, node less than mesh, nodal analysis. When both are equal, if current is our question, mesh analysis. Voltage, nodal analysis. That's all I know your comparison between nodal analysis and mesh analysis. Types of source, one is the current source, another is the voltage source. Current source again divided depending on dependency. It is of 2 types: independent voltage source, dependent voltage source, independent current source, and a dependent current source. Again, dependent voltage source is of 2 types. One voltage source depends on some voltage, and voltage source depends on some voltage. That is voltage dependent voltage source. Another is one voltage source which depends on some current. That is current dependent voltage source. Voltage dependent voltage source, current dependent voltage source. Next, current source of independent type and dependent type. Dependent type again 2 types: voltage dependent current source and current dependent current source. Independent source of dependency on 4 ways. Voltage dependent voltage source, current dependent voltage source, current dependent current source, voltage dependent voltage source. In short form I can write this VDBS, here CDBS, this can write VDCS, here VDCS. Okay. Again, independent sources are divided depending on the ideality. One is the ideal source, another is the practical source. Ideal source means a current source, it does not have any resistance across it. A current source, it does not have any resistance across it. And a voltage source, it does not have any resistance, that is known as a ideal voltage source. And a practical current source is defined like this: a current source with a resistance in parallel with it or across it, and voltage source having a resistance in series with it. This is a practical source. These voltages we are using or currents we are using, these are practical. But ideally this, if we in a question asked what is the resistance across a ideal current source, that means see, across a ideal current source, Ri ideal equals to infinity open circuit, means infinity resistance. If in a question, this is for this, if in a question asked what is the resistance in series with the ideal voltage source, the ideal voltage source R voltage ideal equals to 0. This resistance is short circuited, resistance is 0. In ideal case, in voltage case, resistance 0, in current case resistance infinity. If you put this value equals to 0, it will short circuit. Yes or no? It becomes ideal. If you put here infinity, it is open circuit. So this source becomes what? Ideal. So we will study now with the source transformation. We will see that source transformation will be practical current source to practical voltage source, practical voltage source to practical current source. Okay.